Welcome to the next section of our transformations unit, and we're going to look at stretching and compressing graphs of functions today. So if we're just looking at vertical stretches or compression, you're going to see some value in front of the f of x, where a is a number. And to determine what our new point is going to be, you're going to change from the original function xy point to xay. So when a is a proper fraction, we get a compression by a factor of a. When a is smaller than 1, we get a stretch by a factor of a. So let's just say, for example, that we're given y equals 2 f of x. We say that f is stretched by 2 vertically. That's how we would describe that transformation. Or you could also say f is compressed by 1 over 2 vertically. This way is not as common, but you are still correct. This is the most common method to describe it. So that f is stretched by 2 vertically, and you would know because we see a 2 in front of the f of x. And this impacts all of our y values. If you have a negative value for a, that means we get a reflection in the x-axis. And if you need to describe your transformation in words, you're going to say f is stretched 2 vertically, and there's a reflection in the x-axis, and that is if a is negative. The other one we're going to look at is horizontal stretches and compressions. I need you to make a change here, so I've written it right here. This is what you need to have instead. That our point xy on our original graph is going to change to 1 over bxy. So this b value here, you're going to do 1 over b to get the new value and multiply it with our original x value. For example, let's just say we have y equals f of 2x. We explain this as f is horizontally stretched by a half, or f is horizontally compressed by 2. So one of these are fine. If you want to find your new x and y points, you're going to use this following transformation. xy will change to 1 over 2 times x, and then you leave y alone. If our b value is negative, then we also have a reflection in the y-axis. So if you need to describe that, your transformation words, you would say that there is a reflection in the y-axis along with horizontally stretched by a half. Now let's look at actual examples. We are given a graph, this is f of x, and we want to graph the new graph of y equals negative 2 f of x. Since we have a number in front of the f of x, this is going to be a vertical transformation, and it's going to be a stretch or compression. So if I want to change my original value to figure out what my new x and y value is, this is a vertical stretch or compress, so it doesn't affect any of my horizontal places like my x values. If I want to find my new y value, it's going to be negative 2 times the old y value. Now I'm going to pick a few points from our graph. So we have one at negative 2, 0, we have one at negative 1, 1, and then we have one at 3, negative 1. And I'm going to perform that transformation on them. The x values will always stay the same, but we're going to multiply our y value by negative 2. So this is just going to be negative 2, 0, the same point. We'll leave negative 1 alone for our x. Then we have negative 2 times 1, which is negative 1, negative 2. Then we also have a point at 3, negative 1. Once I transform this, negative 1 times negative 2 is positive 2. So I'm going to graph those new points. And connect them in order. So that's what our graph looks like. If we want to state our transformation in words, you are going to say that we vertically stretch, or there was a vertical stretch of 2. And you would also say that there is a reflection in the x-axis. So that is how you describe the transformation. Example 2, use the graph y equals f of x shown to graph f of 2x. So now we're looking at a horizontal stretch or a compression. So the original point xy is going to be changed to a half xy. Be careful, you don't just take the 2 and plop it in there. You have to do the reciprocal of that, which is 1 over 2. And that is a major thing to remember. A lot of people forget that. That's just kind of the same as if you're doing a vertical stretch or compression, but it's not. So be careful. Okay, now we're going to pick those points that were given to us from our original graph. And then we'll perform the transformation on them. Okay, so -8, we're going to multiply that by a half, and then we'll leave the y alone. So this is -4, 0. Our next one, half of -4 is -2, and then leave our y value alone. 0 times a half is still 0, leave the y alone as 0. Half of 4 is 2, leave the y alone. Half of 8 is 4, leave the y alone. So we're going to graph these points. And then graph them in order from left to right. And that is our new graph. If you want to describe your transformations, you're going to say there is a horizontal stretch of a half. You could also say horizontal compression of 2. One of those are absolutely fine. Now let's do an example where we combine both types of transformations. So from our regular xy, we have a horizontal stretch or compression and a vertical stretch and compression. So the horizontal one, we're going to look inside of the bracket. And this will become a half x. For your y, we're looking at the one on the outside of the g of x. And this is going to be exactly what we see it as, a half, negative a half times y. So in other words, the inside here affects your x values, the outside here affects the y values. Okay, and then we're going to write down the points that were given to us in the original graph. So -4, 0, -2, 4, 2, -4, and 4, 0. You can also do 0, 0 if you wanted to, but it's not necessary. Now we're going to perform the transformation on those points. So this is going to be a half times -4 and negative a half times 0. That's going to give us -2, 0. Then we'll do it for the next point. -2 divided by 2 is -1. 4 times negative a half is -2. 2 times a half is 1. -4 times negative a half is +2. Lastly, a half times 4 is 2. 0 times negative a half is 0. Now we're going to graph these points. and then connect them from left to right. That is our transform graph. If you want to describe this in words, you're going to say that we had a vertical stretch of a half. You could also say vertical compression of 2 if you wanted to. Then we also had a reflection in the x-axis from the negative being in front of the half. And then we also have a horizontal stretch of a half. Or you can say horizontal compression of 2. You don't need to state this every single time you need to draw a transformation graph, but there are a lot of questions on the final exam that states you to describe the transformation in words. So I just want to keep doing that with you so you know how to describe your transformation in words. Lastly, for this question, it says find the domain and range of each function. So for g of x point is at -4. Our most right x point is at 4. Our lowest y value is at -4. Our highest y value is at 4. Now if you look at the graph of y, which is our transform graph, our domain is now -2 to 2, and your range is also -2 to 2. Do this, try it yourself. The first thing you want to do is write out your transformation in terms of points, and then pick a few points from the graph that's given to you, perform the transformation, and then graph it. So go ahead and try this. Okay, so if I want to find our transform point, we have a vertical stretch of 2. And if you look on the inside, this affects our x value, and this will be a stretch of 1/4. Now we need to pick a few points from our original graph so we can perform this transformation. I'm going to pick this one here, 0, 0, 1, -2, and then we could pick maybe our x-intercepts. Okay, so that point is at -1.8, 0. Next one's at -1, 2. Then 0, 0, 1, -2, and then 1.80. So if I divide -1.8 by 4, we're going to get about 0.45, -0.45. We'll leave 0 alone because 0 times 2 is still 0. Now I'm going to do it for my next one. That'll be -1/4. 2 times 2 is 4. Then we'll still get 0, 0, 1/4, -4, and then lastly 0.450. So I'm going to go ahead and graph this here. And then we're going to connect those points from left to right. Looks something like this. And then you do want to connect it a bit because these do go on to negative and positive infinity, so you can just draw arrows on each end for your end behavior. Now our domain, negative infinity to positive infinity, range, negative infinity to positive infinity as well. And that's for both, because it's a polynomial, and transformations of a polynomial will still yield